Hello. So, today we will discuss one of the important aspect of cloud computing or any type of this sort of service oriented mechanisms, like cloud or distributed system or grid or any type of systems, that is the resource management, right. So, what we are thinking of cloud, we are thinking that cloud is a infinite resource pool. Along with that, we are basically leveraging these resources to multiple users, right. So, from the customer point of view or the user point of view or the consumer point of view, that it is a scalable service and a consumer can get as many as resources based on something of the concept of pay as you go or metered service, right. So, from the provider end, it is important to properly utilize the resource in both terms, that it can serve the consumer in a better way, and in other sense also it is limited or a what we say finite amount of resource, it can serve as many as customer as many as consumer of the customer. The thing is that from the providers, there is a business angle also, right. He need to optimize the or to maximize his profit without compromising on the quality of services or the SLA violations, right. As we have seen, if there are violation of SLAs, it has a long implication, it has to give penalty and so on and so forth. There is another aspect of the whole thing, right. Even if I have even if the a particular provider has say money or has can afford number of resources, but there is a limitation or there is a overall environmental aspects of it, right. How much of your carbon footprint, how much energy resource you are having. So, it is there is a restriction or there is a obligation on that point of thing. So, keeping all this thing into mind, this resource management plays a important role in the thing. So, what we will do in couple of lectures, we will to look at that what are the different aspects of resource management in the context of cloud computing. So, if we look at different type of resources in a typical cloud computing things. So, what we have, as we have mentioned, we have infrastructure, right. So, basic infrastructure where is a compute resource, storage resource, networking resource or related resource on the things. There is a platform which is above the infrastructure, or here if I say that infrastructure as a service is the major thing, then we have a platform as a service, and at the end we have the application as the resource, right. So, the resource can manifest in a different way, it can be the infrastructure, though primarily when we talk about resource or resource management, we usually fall back to infrastructure as a service, but considering the overall cloud or overall operation of the cloud. So, basically at least we are having infrastructure as a service, platform as a service or software as a service. Also, we have infrastructure as a resource management thing or platform as a resource management thing and application, but though prominently infrastructure plays a bigger role. So, these are the different type of resources, and the customer basically hook into the cloud with different type of heterogeneous systems. It can be servers, it can be laptops, maybe smartphones, tablets, desktop and so on and so forth. Number of cases, a cloud we can say that a cloud or a service can take the cloud service or service providers thing to leverage on other things, right. I provide service taking some service from service provider and so on and so forth. So, overall this management and optimization of this overall operations is a very tricky one. So, what we try to look at today is that what are the different aspects of the things as at all, whether with the same type of hardware and other things available is it possible to manage the resource in a efficient way. That is our basic call for this particular resource management. So, as we have seen, resource type can be physical resources, like as we see that computer, disk, memory, databases, network, scientific instrument. So, database is again it is a soft resource. What we say that integrated is means that hardware systems meant for these databases, and also there are other logical resources like what we say. There are applications like communication applications and other applications, executions of some processes which execute on the CPUs, monitoring and management of the things, right. So, these are monitoring tools, management tools, etc. These are different other resources. Some resources are directly utilized, right, like if I say that CPU and a disk and other things, some are basically meant to manage those resources, right. So, if you look at in a broad term, like what we are trying, or what if we say that resource management, what we want to do with a resource management, the term resource management refers to the operations used to control how capabilities provided by the cloud resources and services, there is a typo, can be made available to other entities, whether users, applications, services in an efficient way, right. So, what we want to do that whatever the resources and services, that means hard and soft resources, are available with the cloud, how it can be made available to the external entities, like it may be a user, it may be application, it may be a services in an efficient way. So, there is quote unquote the term efficient is tricky, because efficient means it can be efficient in maximizing the profit of the ISP, it can be efficient in energy optimization, or in efficient in giving or respecting SLAs and providing best quality of services, right. Nevertheless, the resource management plays a role in all those things. Now, if we look at data center power consumption. So, what we are referring at, that is a ISP or a internet is a CSP or a cloud service provider. So, they are having data centers, right, like major providers like IBM, Google, Yahoo, or so there are several things like Microsoft, Amazon, and so on and so forth. They have huge data centers across the world, right, as we have seen. So, based on the things that these resources are outsourced from this data center, to be more specific. So, what is the power thing? So, there is some report, it may not be the very recent report, it is much higher than the whatever we are talking about. So, it is estimated that servers consumed around 0.5% of the world's total electricity uses, right. So, it is a huge amount. Now, if it is not only the server, right. If you look at a data center, so data center is if you look at it, there are two major components. One is that compute infrastructure, another is what we say overall environmental infrastructure, right, or data center other logistics, right, what we say environment or logistics of the data center, right. So, what we want to do, these basically gives you say servers or say storage and maybe adjoining thing like network, etc. These are providing primarily looking for your power management or power supply or air conditioning, right, and other related stuff which is related to this data center things. So, if I have a DC, so it has two components. Incidentally, these two have if not equally power hungry things, right. So, if you look at the amount of power, so here what we so if we make it, so we have one, if we have DC, one component is towards compute, one component is towards maintaining the overall environment of the data center. So, here what we having servers, storage, network and other, whereas here primarily your power management, maybe UPS sort of power, then AC and other overall logistics arrangement or other means different type of setups and etcetera to have the house the data centers, right. Now, there is a power requirement out here, there is a overall power requirement out here, right. So, if you look at the, and not only that, this is not only power, there is a power comes space, power comes space. So, if you look at the overall things are, if I say the overall consumption here is x, so it is also somewhat towards x. So, it is the, if it is not only the servers, but the consumption by the other type of other logistic units are equally high. So, when we talk about data centers where it is 0.5% of the world total uses. So, if you look at, if you basically make provision for other things, it may go above 1% of the things, right, over power. And this is some data which is reported in some places, but it may be much higher. So, and it is also saying these servers demands, some report says that energy demand for the servers are increasing every 5 to 6 years, maybe becoming double. There is a large volume of carbon dioxide footprint, which because of this fuel burning of these fossil fuels, need to reduce energy use for the minimal performance. So, what is our goal, that we need to reduce this energy utilization with minimal effect or the compromising this performance, right. So, there should not be practically, or that should not be very minimal impact on the performance. So, that is one of the goal. So, as we are discussing, so the overall motivation, if we say that want to make quote unquote green data centers, which will take very less energy, perform at the highest level. So, there are different aspects. So, one is this economic aspect, the new data centers run on megawatt scale, require millions of dollars or millions of money to operate. Recently, institutions are looking for new ways to reduce, different type of new ways to reduce cost. Many facilities at their peak operating stage cannot expand without a new power source in some cases, like if I have, even that is why I was talking, that even if I am having a fund available as a provider, but I do not have any resource to do that, right. Suppose we have a data center at IIT Kharagpur and we are taking power from the state electricity board, and even tomorrow we say that we want to scale the thing to double and we are ready to pay, but the state electricity board may not have that type of surplus power to supply. So, it is not only that whether I am having money or having more space etcetera, but whether that can be supplied. There is a definitely environmental aspects, and there are different type of legal obligations which for towards environment comes into play. Majority of energy sources are fossil fuels still to date. Huge volume of carbon dioxide emitted each year from power plants, which creates environmental hazards. Sustainable energy sources are not ready to handle such huge requirement of the data centers, need to reduce energy dependency. So, we need to have some mechanism to reduce the energy dependency. So, this is the two very broad aspects of the thing. So, whether we are talking about green computing in this respect, definitely. So, what we can do, what cloud providers tries to look at is that whether these advanced scheduling schemes to reduce energy consumption is possible, right. So, that which can be power aware, right, or thermal aware, both power aware and thermal aware, this sort of things. Performance per watt is not follows the Moore's law, like our famous Moore's law, but it is unlikely that performance per watt is not following the Moore's law. So, data center design, so that whether we can redesign or basically design the data center to reduce power usage effectiveness, so that we can have effectively use the power, like it can be cooling system or the rack design or the placement of the racks and type of things, that is more of the data center design. As we are talking just a couple of minutes back, that one is that having the server etc. compute part of it, another is that data center design aspects of it, that how efficiently you can design. And if you those who are visited some sort of data center, you know that there are different typical arrangement of the cooling. It is not conventional cooling of the, may not be the whole server room of the space. It is a separate enclosure made on the data on the major server racks, and the server racks are cooled specifically very on a very confined area, so that the energy required for this cooling purpose can be minimized. So, there can be different type of research direction, and some of you who are interested may be doing some research on the cloud computing. So, there is a important this resource management, looking at different aspects, is extremely what we say hot topic to do research. There at different parts of the world people are working on this, that how to optimize this resource, how to have a optimal resource utilization for without compromising services or without compromising the performance of the cloud. So, how to conserve energy within a cloud environment? So, one may be schedule VMs to conserve energy, whether we can have proper VM scheduling on the conserve energy. So, management of both VMs and underlying infrastructure, minimize operating inefficiencies for non-essential tasks, right. So, that whether we can minimize that operational efficiency of non-essential tasks, like if you take a VM with a particular flavor and lot of resources, a lot of other packages etc. running, but practically you do not require all those things, right. Whether we can have a tailor-made VM or tailor-made OS which can be run on the thing, right. Optimize data center design, the other aspects. Now, these are, so one is aspect of scheduling the VM, one aspect of is management, another aspect is design of the data center and so on. So, these are three broad aspects. We will try to have a quick look on these aspects, so that we can have a feel of it, right. So, if you look at this overall green cloud framework, so one side is towards VM controls, right, how this VM scheduling management, other side is data center design. So, this is more on the compute side of it, this is more of the data center infrastructure side of it. So, here the infrastructure is the hard data center infrastructure, the other component. So, if you look at the VM controls, so one part is scheduling the VM, so which can be power aware or thermal aware, looking at the things. Other is that VM management, which is VM image designing, right, when whatever the VM image having, whether we can have a efficient design of this VM image with the basically only those packages or those services which are required are uploaded there. So, other is that that is whether you can look for VM migrations, like. So, what we are having that actually if you look at it, so what we are having a underlying hardware and their VMs are there. Suppose there are typically say 16 blade server. So, every blade server is running say 8 VMs. So, 16 into 8 is the total number of VMs are there, right. So, now out of the 16 into 8 or say 10 VMs, so 16 into 10 VMs are running, or say 10 may be on the higher side. So, 16 into 5 say 80 VMs are running. Now, 80 VMs if there are at any point of time say 10 or 20 VMs are active, whether it is efficient to distribute over the whole VM servers available, or I can concentrate the VMs into couple of servers, right. So, because whether the one is that whether the server a VM is running on a server or not, it will go on consuming a base energy, right. Whenever I run a VM, it may consume some incremental energy. So, based on that, it required some sort of a simple mathematics to work out that whether it is efficient. So, on the data center design side, one is that server rack design is an important aspect, and there is separately, if you look at, though not the cloud computing part, this is another research on the building of data center or infrastructure type of things. Air conditioning, recirculation is type of another aspects of the things. So, there are, if you look at that management side, there is another aspect of dynamic shutdown if the things are not utilized. So, whether I can dynamically shut down the things. So, there are a lot of aspects, and if you see, these are all have lot of research potential, especially this part of the things on the compute side. So, this is a typical example scenario. If you see, there is a nonlinear relationship between the number of processor used and the power consumption. So, it is not like that the number of processor used and the power consumption is a linear thing. So, if the number of processor goes on high, the power consumption is basically somewhat going towards some saturation. If not saturation, the increment is not linear. So, whether we can exploit this one, whether we can schedule VMs to take advantage of this relationship in order to conserve power, right. So, that means as I was talking that I want to concentrate my VMs into the underutilized servers, so that the number of servers, the VMs running on the number of servers are reduced. So, that effectively I can put this that is idle servers into sub hibernate or mode or low power consumption mode. So, that the overall power consumption of my data center reduces. So, that schedule as many VMs once on a multi-core node, greedy scheduling algorithms we can do. There is a snapshot of a greedy scheduling algorithm. You can basically try out and see that how things work. Keep track of the core on a given node. So, we have to see that at a way for a typically in a node that how these codes are being busy, or how many how much loading is there. Match VM requirements with the node capacity. If it is there, then whether we can migrate the thing, right. A simple very vanilla type example. So, if I have 4 nodes, right. So, that it is in idle condition or when a low load condition, they consume 105 watt, and when it is loaded, fully loaded with 8 VMs, it consumes say 170 watt. So, if I have some 8 VMs, then if we run on a one node, the overall consumption is 170 plus 105 star 3. So, that is the overall consumption for watts, right. In this case, this typically looking at the things. When if I had it been, it is distributed in things. So, with this sort of load 2 VM, let us say it is 138. So, I have 4. So, in this case 552 watts, right. So, that exactly what we want to see, that in doing so we can basically reduce the things, but there is a little catch in it. Now, in order to achieve from this stage to this stage, I need to migrate this VM. Migration also have some cost, right. Migration has some cost. Not only that, here we are taking all VMs to be the same category, right. So, VM can be of different categories. So, it may not be able to put all the VMs into a one node or two nodes, etc. So, we need to check and monitor that how much loading is there, how much free VMs are there, so that we can basically migrate the VMs, right. So, it is not like straightforward of multiplying that wattage, it is also this migration has some cost on doing that. So, what we need to do? Monitor cloud usage and load. When load decreases, live migrate VMs to more utilized nodes, node, right, shut down unused nodes. So, that I can basically what we are doing, we are compacting those things into the server things, right. So, that is the live migration. Now, number of your hypervisor or say number of VMM do support this type of live migration, though it may be commercially costly, but you can do a live migration, and it has lot of implication other way also, like if a server is having problem, then you live migrate to the other servers and so on, but those are things are possible. So, when load increases, so we can have some sort of wake up call, right, wake up on LAN sort of things to start the waiting node. So, when the load increases, I basically give a wake up call to the nodes which are sleeping to wake up, schedule new VMs to the new node. So, there are technologies available, and if we can be efficiently used, effectively we can have a energy efficient thing, like so that it is node 2, it is migrated there, the VM is put into service, then the node 2 become idle, then made into hibernate or offline mode, right. So, effectively I am running on a node 1. So, it is this, though there is a cost of this sort of a migration, but if overall if I am achieving efficiency or in terms of power consumption, then that may be a good option to look at. So, another aspects what we have seen that management wise, that whether I can minimize VM instances, right. VM machines are sometimes too loaded. So, lots of unwanted packages, unneeded services are there, right. So, you take some while VM it comes with a basic configuration there which may not be utilized by the consumer. So, are multi application, VMs are multi application oriented, not service oriented in number of cases. Clouds are based of a service oriented architecture. So, it is we should have service orientation. Need to customize lightweight Linux VM for service oriented science or services, right. So, that we need to have a customized Linux VM or customized VM per se, right. Need to keep VM image as much as possible to reduce the network latency. So, if we have the VM image less, then the means while carrying of the network, the latency will be minimized. So, these are different aspects. So, this is a typical example scenario with which starts with a Ubuntu typically 9.04, remove all packages which are not required, like if I do not require X11 or Windows Manager, etc., read ahead profiling utility, reorder the boot sequence, so that I can have a prefetch boot files on the disk, minimize CPU idle time due to IO delays, etc. So, I can have a read ahead things, like if I have that the steps to be followed, I can do a priori thing. Optimize Linux kernel built on, say in this typical case, built on DOM-U. So, there is no 3D graphics, no some, so that I can have a customized Linux kernel which is primarily used for the things. So, based on the type of customer requirement or based on the services, we can basically optimize this type of stuff. So, there are different energy saving some snapshot parameters, like we can if it is reduced the boot time from 38 to 8 seconds. So, effectively we can have energy savings, even if a small cover 100 images per hour. So much energy savings can be there. In a production cloud where 1000 images are created every time, saves a lot of energy in other way. Image size from 4 GB to something 600 plus MB. So, reduces live performance, as we are telling that the live migration also is comes with a cost, and we can do better. So, what it is trying to say, that all those things makes its energy efficient or have a proper resource management without compromising the actual performance. So, if we try to summarize, so it is a emerging topic definitely. So, need to conserve energy wherever possible. So, one is that green cloud framework, power aware scheduling of VMs, advanced VM and infrastructure management, specialized VM images or customized VMs images. So, small energy savings result in a large impact, right. So, even it is a apparently VM wise or node wise small, but considering the whole thing there is a large impact. Combining a number of different methods together can have a larger impact than when implemented separately. So, it is not only piecewise, having a collective or cooperative way of looking at it. And there are a lot of research interests and things combine concepts of power aware and thermal scheduling, power aware and thermal aware scheduling to minimize both energy and temperature. Integrated server rack cooling strategies. These days racks are coming with integrated cooling, power and so on and so forth. Further improved VM image minimization, looking at that customer needs and type of things, customer profiling, designing next generation cloud computing system to be more efficient both in terms of energy, thermal and type of service provided by this. So, with this let us conclude today, and as we understand there is a lot of scope of doing research and further studies in this particular way of resource management. Thank you.